added and get started. All right, so good evening, Deltas. Welcome to tonight's class. I believe that we're now in week 4, which is kind of crazy. It's almost been a month. So congratulations on making it through. Tonight's topic is going to be a bit about advanced functions. So I know for the past few days, you guys have been doing stuff with recursion and regex. And tonight we're going to expand on that toolbox of slightly more unorthodox and advanced methods by talking about two of my favorite things, which are lambda functions and list comprehensions. So before we jump into coding, does anybody have questions about the schedule, any assignments, any specific problems from previous class that you guys want to go over, anything like that?
It'd be nice to go over the regex thing again, especially that last question on the challenge, which is formatting.
Oh, okay. Let me go ahead and pull that up real quick. So which one is that, the phone numbers challenge or a different one?
Yes, it's the phone numbers.
Okay, cool. All right, so I'll go ahead and pop the link to this one in the Slack channel, just so that everyone has it for reference. Does anybody interested in sharing their solution to the phone numbers challenge with the class by any chance? Want to talk through what they did? Okay, I'm going to take that as a no, but if anyone would like to present their solution, please let me know, because it's always nice to hear from you guys about what sort of things you guys did to solve it as well. Okay, so let me go ahead, pull up my VS Code, right, demo. All right, so can you guys see my screen okay?
Yep.
Okay, cool. So let me go ahead and just copy paste the problem text. Find that again. All right, so I'm just going to do regex on some phone numbers, and I'm not going to clone this whole thing down just yet. Let me at least copy into that file here, and then we'll also just copy over part of the spec in here too, just so we have this for reference. Okay, so you specifically had a question about the format phone number, right?
Yes, I mean that's where it took the longest for me, and I think maybe one or two people in here don't know really. I just my feel is that that was the most challenging part of the whole thing as well for others.
Okay, that is probably the most logistically complicated part of it. Did anyone want to go over any other parts of this challenge as well, or just the last one? Okay, so I'm assuming we just want to go over the last one then. And that's totally okay. So where can we start with this, right? So if we go up to, let's say, actually, yeah, where can we start? So what are the two things that we need to do for our format phone number function? Well, we can break down what needs to happen in two parts. So what are the two things that we need to address here?
I think we need to identify the pattern and something to replace that pattern with in a string because I probably should use the function sub, which takes a pattern replacement, and I think that would probably work.
Okay, yeah. So going back to what you said, we need to basically extract phone number using pattern somehow. We need to get the phone number out. And after that, we need to reformat phone number for application. So if we go through any of these, oops, not the test cases. Do we have anything that can format? So let's do thing 2 first, because that's probably the easier one. So what would reformatting the phone number? So let's say that if by extracting the phone number, let's say phone number extracted in like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So how do we reformat this to the nice thing with dashes? And let's say that what we can call that phone number like extract. So how do we reformat it?
I grouped mine with parentheses, and then by using substitute, and then when I called on them like to fix them through substitution, I just said like group 1, like reformat to group 1, and then a dash, and then group 2, and then a dash, and then group 3.
Ooh, interesting. So what you did then is instead of taking like extracting the whole number, you extracted like the first 3, the second 3, and the last 4. Is that correct?
Yeah, and then using re dot sub, I just said call group 1, like print group 1, and then a dash, and then the following groups.
Interesting. Okay, cool. Would you maybe like to show us your code and how you did that?
Yeah, I can do that.
Awesome. Go for it. You should be able to share your screen now, by the way.
Okay, can you see that?
Yep, we can see it.
Okay, great. So this is the one that I use. At first, I just said get rid of like all special characters, and then replace them with a blank string. So that will return like 1, 2, 3, 4, 5 with no spaces. And then I just use sub to get a group of like the first 3, and then the group of the next 3, and the group of the last 4, and then replaced it with group 1, and then a dash, group 2, then a dash, and then group 3. And then it should return a list of all the formatted numbers.
Okay, interesting. So yeah, that's definitely one approach to take. And this is quite a unique one. I feel like I haven't seen too many people do it this way. So thank you for sharing that. Did anybody do it a similar way to Austin or try something different?
Yeah, I did a similar way to be able to the last part that he showed. I had something similar with the 1, 2, and 3. The first part I had, I guess, a more difficult time to do. So my reformatting at the beginning was a little bit different.
Okay. Would you like to show us what you did for the reformatting as well?
Yeah, sure. That way we can do, I guess, a comparison.
Yeah, it's always helpful, especially for things with rejects. There are so many ways to extract like a substring. It's always really nice to see the different methods that the people use.
Elijah, do you have goats?
Yeah, yes, I do.
That was awesome.
Sorry about that, guys.
I did not expect you to say yes.
It
It makes me happy, so don't apologize.
Okay, apparently I don't have my settings set up right for Zoom.
Okay, no worries. Let me
It
see.
wants me to restart the application or something.
Oh, okay. Yeah. Feel free to do that if you want to, and I can
Okay,
let you right back in. So
Okay,
yeah.
thank you.
Yeah, and if anybody else has that problem as well, I know that sometimes like doing like a Zoom update or something, it will tell you to restart the application to screen share. Feel free to just restart it, exit, and come back. It's no big deal. Okay, cool. Elijah, we can see your screen now. So go ahead whenever you're ready.
Okay, so this is the last part that formats the phone number. And I started out with assigning the substitution as a variable. So I don't know if this is the best way to do it, but it did work. So I did the first line. I did anything that is not 0 to 9 or the comma. I wanted to replace it with nothing inside of the input string. And then I took another substitution that I later had to figure out because I needed the space after the comma. And then lastly, I did a third substitution to do the grouping where I had anything that had a group of 3 digits and then another 3 digits and a 4 digits. It would do one, the first group, a dash, second group, a dash, and then the third group. So that's how I was able to solve it.
Awesome. Okay, thank you very much for sharing that.
Thank you.
So yeah, so I like how both of you guys tried like stripping everything down, except the numbers, which I think is a good approach to take. And then after that, reconstructing the number from it, which is quite interesting. One thing that I am wondering though, did anybody, instead of using sub, try using something like the find all function, or a different method, or was the general consensus of the group just to use the sub function?
I think I tried using find all at first, but I think I was just writing it wrong and it kept giving me like an error. Or it kept like returning the wrong thing. So then I ended up switching to sub.
Okay, cool. So yeah, sub is definitely, sub and find all do have two really different uses. Like sub is just used if you want to replace, or in your case, if you want to delete something. And find all is just, it comes back with all the strings that have some criteria in it. So what you guys would be doing is like basically flipping around the sub and find all inputs. So let me see if I can pull up my VS Code one more time. There is some code that will let us actually use find all. Yeah. Okay, so that's at least the approach that I would take. Let's do a import. Here we go. That should work. All right. So if we look at, let's say, I'm just going to call it extract numbers. We do re.find all. And I'm going to move this out of the way. There we go. So what does it tell us here? It says that it's going to return a list of all non-overlapping matches in the string to this pattern. And here, we'll just keep that blank for now. If we do like sub numbers, and we do re.sub, it says it returns a string obtained by replacing the occurrences of the patterns by whatever thing it is. So for us, what we could do is for the find all, it would find everything, say, with that specific 3-number structure. But for sub, we want to find everything outside of that 3-3-4 structure. So what we'd be writing there is diametrically opposite. So let's go back to the find all, because this is an important function that I want to make sure that we all know how to use. So first off, how would I find groups of 3 or 4 numbers using find all? What's the regex that I would use for it?
You could do that a /D and then specify how many, well, with curly brackets, specify how many occurrences you're looking for, but then I guess since if you're looking for more, you'd have to, I suppose, put it in a capture group.
Yeah, so that's how we would start this off, right? We'd say, okay, identify for me 3 numbers, 3 more numbers, and 4 numbers. But now we have a problem because we know that there's going to be things in between our groups of 3 and 4 numbers, right? So how do I tell it, hey, there's going to be a bunch of just like gobbledygook between like the 3, 1, 2 and the 1, 1, 1. How do I tell it that information?
So my solution was cumbersome, especially compared to what everybody else's pull request, but I did use find all. And then for my regex, I just grabbed, excuse me, all the numbers. That's just all I did. So I just did my regex was just /D plus. And so I just grabbed the numbers and then reformatted it later to insert the dashes. But
So you said you did an RE dot find all, and then what did you do after?
so my regex was, so I had just, I had made the regex as a separate variable, but my regex was just simply, /D plus. And that will just grab all the numbers. I made the assumption because all the test cases were everything had exactly the same amount of numbers. This wouldn't work if it was more, but for the case that at hand, it worked for that.
Interesting. Okay, that is actually a really simple approach, but I like it because it works perfectly given the constraints of the problem. You are fulfilling what the client, or in this case, what the problem demands without overcomplicating anything. I think that works really well. The solution that I would do, and that some students in other cohorts have done, is slightly more complicated, but I feel like it works as well. But your solution does work and is really nice and elegant. So thank you for sharing that. But yeah, really quickly, the one that I would do is I would keep this 3, 3, 4 up here. But the other thing that I would do is put a dot and a question mark and keep doing that in between all of these numbers. Does anyone know why I might want to do that? Or what actually, here, we can just leave it out at the beginning and end. Does anyone know what that dot question mark means, or why I might want to include it in between the 3 and 4 number bits?
So it's doing like an optional character, but it'll pick up anything if they use a dash, a dot, because the dot covers any character in that spot.
Exactly. Yep. So that's what the dot's for. So the dot says, all right, whatever there is in between this, whatever singular character there is, I want you to replace it. I want you to that out, forget that from the rejects. So that's what the dot would do. What about the question mark? Any ideas?
I think the question mark would say, do that just 0 or 1 times. Like
So
it could only be 0 or 1 characters.
So the question mark, so you're really close. So the question mark does is it says, all right, however many times you could do it 0, it could not be, that character could not be there. There could be one thing there, or this is the magical part, you could have like 150 characters there. And the question mark will pick that up. It basically says as many times as needed that you need to skip over those, the question mark lets you do that. So the dot question mark, it basically says, all right, I want to skip over as many nonsense characters as are in this little space. So basically, if I did something like, let's say 1, 2, 3, typing a bunch of letters here, and then 4, 5, 6, 7, 8, 9, 0, all of these letters that I've selected those would be covered under that dot question. And so they would be skipped. So does that regex make sense? Any questions about that one? Or about the exercise as a whole, or regex, or things like that?
What I don't get with the question mark is like, how come then it won't pick up also the digits in front? Because the dot could be anything.
So the dot could be anything, that's correct, but it will pick up the specific 3 digits because we've told it to look for 3 digits and 3 digits and 4 digits.
So
So
those are insulated from the question.
exactly. So the
Okay.
question mark is basically like anything outside of this pattern, outside of the specified things, we will find.
Okay. Makes sense.
Great. Any other questions about this problem or regex before we move on to the new material for today? Okay. If not, let's see. Let's take maybe a 4-minute break. We can come back together at like 6:12, and then we'll jump into the lecture for today. It'll be a little bit shorter than usual because there isn't too much stuff to cover. But hopefully you guys will have fun working on the problem for today, which is a bit of a unique one. So yeah, we'll come back together. Let's make it 6:13. So yeah, feel free to turn your mics, cameras off, grab a drink, whatever you need to do, and I'll see you guys in 4 minutes. Yeah, let's get it going. And let's go pull up. Yes. All right. So before we jump into lambdas and list declarations, though, there is one thing that I do want to talk about, which is related to the way that we talk about code. And not just that, but also the way that we pseudocode things, which is declarative versus imperative code. So have you guys heard of these topics before by any chance?
Nope.
Or has anybody dealt with them? Okay. Oh, go ahead.
I was saying I have not. I haven't heard of them.
Okay, cool. Yeah, these topics are things that are not talked about or encountered all that often, except in like programming discussions. So that is totally normal and more than okay. All right, so let me make some comments here. So declarative and imperative code are usually things that translate really well, or translate over to pseudocode a lot better than they do to actual code. But it's a good distinction as well to keep in mind. So an example of declarative code would be just like a really broad general statement of something that we want to do. So like what you could say is, what would be an example of declarative code? Something like, give me all items in a list that, I don't know, are greater than 5. So this would be an example of declarative code. So basically just like one statement that says the end result. Instead, what we would do in something like imperative code, do the same thing, is going to be like more drawn out. So it'll basically be like iterate through the list for each item in the list, check if it is greater than 5. If it is greater than 5, add to new list, and then return new list. So obviously you can see how different and how cumbersome one of these, like the imperative one specifically, is compared to the declarative code. It's way faster, easier. So now though, what we're going to do is try translating these two approaches in code. So again, this is like, let's say that, the declarative and imperative codes are things that we wrote out in pseudocode, We wrote them out in pseudocode. We have this like giant sheet of pseudocode, and we're starting to program now. So let's start with the imperative code. So how would I turn that, again, line by line through the imperative code? How would I turn what I wrote there into something in Python?
Like for I on list.
Okay, yeah, so let's do for I, and I'll just call it like the list to be very original. So I'll say the list. All right, so what would I do from here? So iterating through the list now. So what's our next step?
Write an if statement.
Okay, so what would our if statement look like?
If I is greater than 5, and then I don't know, I would add it to like a new list or something.
Yeah, so we'll just do, again, very original here, new list dot append I or something, right? And then all the way at the end here, we can just return. Yeah, assuming this was in a function. Okay, so that was our imperative code. Now, note how many lines we did this in. 4 lines. And in addition to that, we also, so our variables in play are going to be the list, new list, and I. Now let's try doing it with declarative code. So now my challenge to you guys is, how can we do it in declarative code in only 1 line? And that is going to be the challenge that we're going to start today off with. Anyone have any ideas?
So I guess where the list comprehension comes in handy.
Okay, that's good. Yep. So
I
how
guess
do I use it?
say I for I in list, if list new list equal, yeah. I for I in list if I is bigger than 5.
Okay, so do I just write it like this? It looks like it's throwing me an error.
I'm not doing it right.
You're really close. There's like 2 characters that you're missing.
Brackets on the outside.
The
Perfect.
brackets, yeah.
And the reason for that is because new list, it's a list comprehension, but it's still a list. And because it's a list, we have to put the brackets around. So this line, 1 line, does the exact same thing as these 4 lines. But one of them is a whole lot neater and more concise than the other. And one of them, and both of them translate directly from the pseudocode. So from just doing this, like, give me everything in a very short written sentence to translating that into code, versus with the imperative, going line by line and like the traditional sort of old school method and still writing out the whole thing. They both do the exact same thing, but declarative code of this nature is a lot cleaner, more concise, more readable, and just better overall. So that was the mini lecture on declarative code. Anybody have any questions about the difference between the two before we move on to the material for today?
Does it matter what side of the so you're doing a for loop there? Does it matter what side your actual function is on like line 3? So like, what if we did if I is greater than 5 before the loop? Because what I'm looking at is in the lesson on the actual curriculum, they do like a doubled equals num times 2 for num and nums. So it's almost like they put the actual what they're doing inside the loop before the loop, whereas on here we did it after.
Yeah, it does. So it depends, I would say, on what you're looking to do. But I mean, if you want to, we can test it and see what happens. You can say, like, I don't know, I'll come up with a list here. So call it 12, 44, negative 15, 3, 7. And here, let me comment. Let's delete that. And we'll just like comment this out. And here we can like print a new list. Just to make sure that everything's working as intended. And if we run our Python script, you see here that indeed we do get 12, 44, and 7. which is exactly what we expect. Now, let's say that we copy this code, comment that line out. Now, let's see what we can try. We could do, Actually, it's pretty much the same format, Matthew, as what's in there, because what they have is like they're just doing something with the number. So what I could do here is like if I wanted to return double every item in the list that's greater than 5, I would just do I times 2 for I in the list. But then the if is like the condition.
Okay.
Yeah. Does that make sense? So they're following the exact same format. But basically, if we want to write it out, it's like thing to be returned for iterator in thing being iterated over if condition is satisfied.
Oh, okay. So you basically break it up into 3 parts there, like it basically on what you want.
Right.
Okay.
So yeah. So I mean, if we go back down to that for loop here, right? In the for loop, what we'd be doing is basically saying like for iterator in thing being iterated over if condition, and then we'll just say like thing to be returned. So it flips the format just a little bit in comparison. I'll just comment this. It flips the format just a little bit around from what it is conventionally, but it's essentially doing the same thing.
Okay. Yeah, that makes sense.
Cool.
Could you say I greater than 5 for I in the list? Would that do the same thing?
Okay, that is a good question. So before I answer that, I want to, and we'll write it out in code too. Quick. I would like to hear some opinions. Do you guys think that doing like that doing this, what do you think that this would give if we just did I greater than 5 for I in the list? What would that give us in our new list? What do you think?
Booleans.
Interesting. Aaron, why do you say Booleans?
That's because you're asking if I is greater than 5 for I in the list.
Okay, interesting.
Return.
Anybody else think differently?
I agree with Aaron.
Okay, it appears that is the general consensus, but as good programmers and good, I guess, pseudo computer scientists, let's double check. Let's test our theory. Let's hit the run button and see what happens. And indeed, we do get a bunch of Booleans. And why? Well, if we go back to that format that I was talking about for our list comprehension, thing to be returned is the first thing in there. The thing we are returning is whether I is greater than 5, right? So if it's not, we don't have any condition at the end of it. So because of that, it doesn't work. Does that make sense? Any questions there?
Yeah, that makes sense.
Okay, cool. Now, I have one more little question. Why can't I write, for example, I for I greater than 5 in the list? Because that seems like it should make sense, right? So why can't I do this in Python?
Well, I greater than 5 isn't really, that has to be the variable you're performing a function or performing some operation on.
Exactly. Yeah. So because of that, I can't say like for I greater than 5 or for like string dot length greater than 10 or something like that. It doesn't make sense because you're setting up the variable that you're using to go through it. So for that reason, it's very similar to what a for loop looks like in structure as well. But again, it's just flipped on its head. So again, like just like in a for loop, I wouldn't be able to say for I greater than 10 in the list, it breaks. It's the same thing up here. And the same thing like for our if statement. Like I can't say like if I plus 2. Like that won't work. Just like if we said that in a normal if statement. So it's the exact same syntax, just flipped on its head a little bit and condensed and written out in one line. Does the idea of what we're doing here with list comprehensions make sense? Anybody have questions about it?
That thing that's on line 8, that's a general guide for how these things are written. Does that ever change, or this is dependable? Like if I write down number 8 and plastered it on my wall, I can look at that every time I need to put a declarative code.
Yes, that is correct. Well, that's not necessarily for declarative code. I should warn you. This is just for list comprehension format. But this is just an example of declarative code. I should say that. But this is list comprehension formatting 101 essential thing. That will not change. But this is just an example of declarative code.
Got it. Thank you.
Yep. Any other questions before we move into more list comprehension fun? Okay.
Is this,
Oh, go ahead.
Does this also work for tuple or dictionary, or just list?
Indeed it does. So why don't we try that out? You're asking some good questions today, everyone. All right. So let's say I have a dictionary, and we're just going to delete this for now. Delete the declarative code bits. So let's say that I have like, I don't know, dict one. It's going to be like, let's say, well, actually, no, before I make the dictionary, how do I make a dictionary in Python again? What's the formatting? What is a dictionary? Anybody just want to talk me through that very quickly before we move on?
Curly brackets.
Okay, curly brackets. What do I do inside the curly brackets?
You're gonna have your key and then colon variable colon value and then a comma.
Okay, perfect. Yes, we'll just do like 1, thing 1, 2, thing 2, 3, just like here. Something like that. All right. So how do I iterate through a dictionary? How would I do it conventional? If I wanted to iterate through this dictionary in a for loop, what would I do?
You do for key in dictionary, that will give you the keys only.
Okay. We'll do for key in dict1. In. And then we can also just double check. We can also print all of our keys. I'm gonna remove all of this unless anybody has questions about it. But let's just double check that this does indeed print our keys, and it does. Now, what if I wanted to print the values? What would I do?
You can say print key, comma, dict at key. That will give you the values as well. No, in the print statement.
Okay, so you said print key and then dict1 key like this.
Yeah.
Okay. I tried that.
Would item work if you do for item in dict1?
Maybe.
You can also do it with the items function, but I thought that I don't know why that doesn't work. dict
That-
one at key. That should work.
That also doesn't seem to be working. Anybody have any ideas?
Key value in dict that items as a function that gives you.
So you're saying to do it in the for loop?
Yeah.
And then you said dict
that
one.
items. That's a function. Like dict out one items, that's a function.
Oh, gotcha. Yep. Thank you. All right, so let's try that. Okay, so that appears to work at least. So if we look at the items function, though, it gives us a set-like object providing a view on these items. Shows us everything that's in dict1 in our key value pairs. But there's also a way to get all of the keys in the dictionary. Anybody know how to get all of the keys in a dictionary from a function?
Is it dict that keys and parentheses?
Yep. Oh. There we go. So yeah, it would just be dict.keys. And it just shows us all of the keys in dict1. And again, if we run this, let's test it out. 1, 2, 3. Those are the keys. Now, what if I want to get the values? How can I get the values of a dictionary in the same way?
I think there's corresponding dict that values as well.
Yep. And let's just change that to values. And we get the values. Okay, so this is how we iterate through a dictionary convention. But now, let's say that I want to do a list comprehension with my dictionary. So let's say that I want to, return index of all, or no, return the keys of all elements in the dictionary whose value has things. And I'll just make like a few more, like 100. I'll say like thingy, and then we can make it 2, 3, 4, and make it like. So how can I write a list comprehension? Or how can I write a conventional for loop? Let's start from the for loop. How can I write a for loop that will do what I want to do in item 7?
You'd use that you'd iterate using tuples with the key value and indict one dot items.
Okay, so how would I do that? Like in a for loop?
I think it would be the way Lazuka explained. So like for key value in dict one dot items.
Okay, where would I go from here?
Oh yeah, you want all the keys. Well,
If state.
yeah, it would certainly be a
What goes inside?
well, since it would be if value equals thing return or print key or push like key to like some other data structure. And then
Okay,
you have all your
yes.
keys.
So we can just call this like a thing list or thing. Say that's like a blank list, and then I'll just say thing keys, pen. We can even do like a dot. Yeah, let's just stick with a pen, and then we can just do. But we have a problem here. So here it says return the keys of all elements whose value has thing in it. But here we're using an equal sign. So how can we check?
Oh, contains. Oh, okay. Yeah, you weren't just looking for a thing.
Yep.
Just a string that had thing in it.
So would I use dot contains? Or would I use another function?
You'd use the in operator.
Okay, yeah. So how would I do value and thing? Or would it be like
Or
value
thing in
dot
value.
Thing in value. And then at the end, because I like using print statements to debug everything, I'll just print out our key keys. Does this code look good before I hit the run button? Is there anything here that looks like it could go wrong or fail or explode my computer? Okay, I'm going to say no. Hopefully you guys say no as well. And if we run this, we see indeed that we get our list of keys. We get key number 1, we get key number 2, and key number 100. And all of those have the word thing in them, have values with the word thing in them, which is exactly what we want. Okay, now we're going to comment out the boring one, but I'm going to leave the print. What I want us to do is I want us to write this as a list comprehension instead of this for loop. And let's say I want to return the keys, I don't know, times 10 or something. So how can I do the exact same thing, but in a list comprehension instead of a for loop and the if statement? So again, let's look back at our format here. So we've got our thing to be returned for iterator in thing being iterated over if the condition is satisfied, right? So what's the thing that we need to be returned? What's the first thing we need returned?
The thing keys.
So, well, I modified it to say it's the keys times 10, but basically, yeah. So what's the first thing I'm going to type inside my list comprehension?
The item you wanted to add to the list.
Yep. So for us, that would be just write keys times for key times 10. All right. So the thing to be returned is done. Now the next part is I need to write my for. And now I need to do the iterator. So what would the iterator part look like? And yeah, this parallels what's in our for loop. So what would I write down as the iterator to go through the dictionary?
You write line 17.
Yeah, pretty much. We would literally copy this over, except no colon at the end. Like it's for key and value and dix1.items. Now I've got my if, and now I need to do if condition is satisfied. And for that, we literally just copy this over. And is there anything else I need to do, or should this work before I hit the submit button? All right, does anybody have questions about what we did here?
That looks good, I think.
Okay. Let's hit this run button, and look at that. So we get the keys. Key was 1, 2, and 100. We're getting 10, which is 1 times 10. 2, which is 2 times 10, and 100, which is 100, or 1,000, which is 100 times 10. So it looks like our list comprehension worked. So one thing to keep in mind, though, I'm sure as you guys can see, these list comprehensions can get really long. So again, this one right here is already taking up like 2/3 of a line compared to this for loop, which takes up 3 lines. For things where you have a lot of different criteria or like many items to go through, list comprehensions can be really long. So I would caution you, maybe not I wouldn't say against using them, because I love using list comprehensions and they're a really good tool to have in your toolbox. But I would always say, think about what you're trying to condense into your list before deciding whether you want to use a list comprehension or a for loop. And most of the time, if you can write it in a for loop, you can definitely write it as a list comprehension, and it becomes really easy to do so. But it's not always the best approach. But for most of our simple things, it's just a lot easier. Um,
I have a
Yeah,
question. Which one is considered more readable on our two examples here? The list comprehension or the for loop?
so right here, like for this specific example, I would personally say they're both equally readable. At least to me, you guys may disagree, and that is totally okay. In general, I feel like for loops are more easily readable, but a list comprehension is far more efficient because it gets the same thing done in less lines and less word characters, which is what matters for us as programmers.
So is that the biggest advantage of the list versus multiple lines of code?
Yeah, pretty much. It's just a lot faster than the for loop. It's just easier. Any other questions about list comprehensions?
Would it be something you could do for, like, say you had a nested loop and you wanted to remove one of the loops and just do list comprehension inside of a loop? Is that something you would ever do?
Oh yeah, for sure. So let's say I have like a two-dimensional array, right? So here, let's delete this. Let's say I have a two-dimensional array, and I'll call it 2D array. Oh, 2D array. There we go. And let's say that I'll make it like 1, 2, 3, comma 4, 5, 6, comma 7, 8. And let's say what I want to do is I want to return list with the sum of each row. So how would I do this normally in a loop, in loops or nested loops? What would you do to do this?
You just have to, I'd use two loops, an outer loop and an inner loop, and then
What would those look like if you were to code it right now?
All right, so you could just do for you could do for like a row and array,
Mhm.
and then for num and array, something
Will
like
it
that.
be for num in the array or in the row?
You do like nested array.
Yeah, or for us that would basically be in the row.
Row. Okay, yeah.
Yep.
That's my fault.
And then let's say we would here I would do something like just like row sum equals 0, or just do like row sum plus equals num, and then down here I'd do like sum of rows dot append row sum. And it doesn't look very pretty, let's be honest. Now instead, what we could do here is we could say something like so first I'll start off with the conditions. I can do for row in 2D array. And now what I want to do for each row is say, so this is where the list comprehensions get a little bit murky. So now we could do a nested list comprehension. And what I could say here is say the num for num in row and for row in 2D array. And does anybody remember how we can sum up all of the items in a list in Python?
Isn't there a sum function?
Okay, so yes, you're right. There should be a sum function. Is there a sum function?
Yes, it's some open and close parentheses, right?
Yep. Then basically what we could do here, we just do sum. And here, let's make it like num times 10 or something. like keep it really easy. And so this is what our a nested list comprehension looks like. Is it as easy to understand as nested for loops? No. Do I recommend doing nested list comprehensions? Also no. Just like I don't usually recommend doing nested for loops. But it's, again, a good tool to have in your arsenal, and you never know when you're going to need to use it. So to answer your question, yes, you can nest list comprehensions just like you nest for loops. Do you want to? It's up to you, but personally, I would not recommend.
So you said you would not use nested comprehension, nor would you use nested for loops. For a problem like this, what would you use?
For a problem like this, I would probably just end up doing something like and that is not what I wanted to import at all. I do not know why I even did that. But basically, keep it as simple as possible. If there's a function that can do it for you without creating an additional loop, use the function every time. Unless it does something that you don't want, in which case don't. But you keep it just as simple as doing this. And equivalently, here, you could literally just say sum row. Again, keep it super simple. But again, so sometimes you might need to do something different. So like what you could say is like return list with the sum of all elements in a row that are bigger than 5. Well, then this solution doesn't exactly work. And then inside here, you'd have to do something like sum of I or I in row if I greater than 1.
The second thing you wrote, does that doesn't that just create a list sum of rows with the sums of the individual rows?
In this one?
No, on line 16 and 17. Like this won't actually return the full sum, right?
No. So this one, so here, let's run it and see what's going on. So if I do, say print sum of run button here. So here what this is doing is it's going through every single row, right? 4 row and 2D array. I start with like the first row, 1, 2, and 3. Then it's going to this sum function. It's saying, okay, and I know I need to sum some things, some list. What is that list? That list is every number for the numbers in that list that are bigger than 5. There's no numbers here bigger than 5. So this ends up being a blank list first. And that's why we get that 0 here. In the second one, it goes through 4, 5, and 6. All right, 4 isn't bigger than 5. 5 isn't bigger than 5. 6 is bigger than 5. So then this ends up being one, only having one element, which is 6. And then the sum of 6 is just 6, which is where we end up with this value. And the 7, 8, and 9 does the exact same thing. And that's why we get 24. Now, this one does not do the elements greater than 5 bit. All this one does is it just adds up all of the items in each row. But if we wanted to make it do all of the elements greater than 5, then we can combine a list comprehension with a for loop. And yes, this is possible. This is something that I have seen many times and I have done myself many times. You can nest a list comprehension inside your for loop, just like this. So hopefully that somewhat answers the question.
Yes, that makes sense. Thank you.
Yeah, sure. Any other questions for now?
Yeah, could you use a method as an argument in list comprehension, or is it only like, I don't know, plain arguments?
What do you mean by an argument in a list comprehension? Do you mean like a thing that's returned?
Yeah, so instead of like instead of saying like for I in row if I is greater than 5, if you had a function or function that like already did that, could you put that function inside the list comprehension?
So you're saying if you had a function that already picked out everything that was greater than 5, right, from your list,
Yeah.
then you wouldn't need the list comprehension at all. Then, because the list comprehension just picks out everything that's bigger than 5. So all that you would do there is you would say like sum of like function thing rows. Because that function would do exactly the same thing as your list comprehension in that case.
Okay.
Whenever you see a problem statement or you end up writing some pseudocode that looks like, give me all of the blanks such that blank is satisfied, or give me all of the items or all of the things satisfying such and such a condition. That's usually a really good use case for a list comprehension. And that's usually something that you wouldn't write a function for. But in a list comprehension, let's say I wanted to run a function on everything that's bigger than 5. Then what I could do is I could return for things. I could return whatever this function is and operate that on each of the individual elements.
Okay, yeah, that's essentially what I was at. I just couldn't word it right, but all right, cool.
No worries. Anybody else have other questions on this note before we move on to Lambda functions? Okay, let's maybe take let's take a 4-minute break. We'll come back together just around 7 o'clock or 7:01. So hopefully you guys will get a nice few minutes of breather before we do the last thing for lecture tonight. I turn you guys loose on the problems. Okay, so we talked a little bit about list comprehensions, but there's one other type of really cool thing that we can do in Python that makes something super concise. How many of you guys have used arrow functions in JavaScript? Okay, I'm assuming this is probably something that has been talked about before. But arrow functions, as most of you guys know, are really easy ways just to find a function that does something extremely simplistic. So if we go back here and say, again, I know that this is in Python, but we're going to pretend like it's JavaScript. If I wanted to just write a function that multiplies something by 2 and adds 3, what would I do to from like my multi 2 add 3? How would I write this function using fat arrow notation?
Put an equal sign, space equal sign, and then you're going to put your parameter or parameters.
Okay.
And then do the fat arrow and then the curly bracket open.
And then I would just basically do num times 2 plus 3. Or, I mean, you can honestly put that in parentheses here and just leave it there. I would prefer doing it in brackets, but you can do parentheses too. But yeah, that's basically how we do it in Java. Now in Python, we can do pretty much the exact same thing. What we do here is we can do mult 2 add 3. And we would just do equals. And now we type in a lambda. And the lambda basically says is the equivalent of the fat arrow function. We put our input, which is going to be num. And then here in our return, we will return num times 2 plus 3. These two, yeah, this is JavaScript. This one is Python. They do the exact same thing. No difference between them. But this is a whole lot easier than say, find mulch 2 add 3, and I'll say num and then colon and return num times 2 plus 3. One of these looks a lot nicer, is a whole lot simpler than the other. But you only really want to use lambda functions for doing relatively simple things. I do not recommend using lambda functions to write out functions that ordinarily would take you like 100 lines of code. It is a really bad idea. But lambda functions are really good for things that you're going to repeat a couple of times. So let's say, yeah, so let's go back to our original list comprehension, right? So we said we want to return, let's simplify it now, and let's just say I want to return all elements greater than 5 in a given list. So how would I write a list comprehension to do this? What would I do? So if I give you a list that says, I'm gonna say like this list equals, I don't know, 10 to 400 negative 135. How can I come up with like list greater than or equal to 5? How can I write a list comprehension that only has the elements from this list that are bigger than 5?
Only do like number for or num for num in this list if num is greater than or equal to 5.
Perfect. So that's how we can do it for this list, right? But now, let's say that I have a second list. Let's say I have 2 data sources, and this list is 1 data source. And then I have another list, which is going to be like 500, 3, negative 4, 5, and like 68. I don't know. And I want to do the same thing for another list, which is our second data source, right? Well, I can't use the exact same code there, but we could do like number 2 and then change this list to another list. But then we get a third data source that I need to run the exact same operation on. And then let's say that it becomes like another list like 3. And then I end up copying this code again. And then I write this with a 3 here and a 3 there. And let's, pretend these numbers are something different. Now we let's say, okay, all of a sudden I have 100 of these data sources and I need to pare each one of those data sources down to only give me the elements that are bigger than 5. This is going to be a lot of repetition for each of those data sources. And now this is where lambda functions come in handy. Because what I can do for each of these lists, I can turn this handy little list comprehension into a function that will work off of any list. So I could say is list greater than or equal to 5 as a function. And here, let's see if this ought to work. There we go. Type lambda and then input list colon copy paste our list comprehension and then just change the list that we're trying to comprehend, change that from this list or another list 3 or whatnot to our just generic input list. And bam, each of these one little lines that originally would be used for a different list, we've now converted that to a function by just adding 3 additional words and an equal sign and a colon. So now what I can do, instead of rewriting this whole thing every single time, I could just run list GEQ5 this list. And I could do the exact same thing for this guy. They can call it another list. And we can do that for number 3 too. And we can do that continuously. So that way, if I have, let's say, 4 data source in 100 data sources, because we've suddenly gone to a production environment and they're throwing 100 data sources at us that we need to simplify, what we could do is say like new data source, or like, I don't know, simplified data dot append list GEQ5 for our data source. So Lambda functions are really helpful when you have simple but often repeated things that you need to do a lot of times. It's just so much easier because you can just put it in a function and just write a really simple little function that you can just call over and over and over and over again. So that's the main use of our Lambda functions. Does anybody have questions about how I set that up? Okay. Does anybody have questions about Lambda functions, list comprehensions, other things of that nature?
Would you have time for another example? I feel like I have a question on Lambda, but it's just sinking in now, so I don't even know what questions I have.
Sure, yeah, we can do as many examples as you guys want. More than happy to. Did somebody else have a question as well before I jump into another example?
Yeah, so I feel like I've seen Lambda used in combination with other methods like map and filter, or reduce.
Yeah,
And
that is
then-
correct.
And then you would use it, like you had to specify, like if you were to use it in filter, for example, you had to specify to look into a particular list. So I think the syntax was a little different.
Yeah. So those usages we will talk about probably closer to the end of module 1, or maybe going into module 2.
Okay.
So that, yeah, but we will discuss those.
Okay.
But for those usually take in like multiple inputs in the Lambda function, which you can have. You can have a Lambda function take as many inputs as you want. It just needs to, the expression can only run on one line. It can only be one expression. But the format is very slightly different for that. You're correct.
Okay.
And Lambda functions, as you said, they can be used as inputs. You'll see that a lot for things like for sorting. Actually, yeah, there's a really good example in the curriculum page. Let me see if I can find that and copy it over so we can go through how it works. There we go. Here, let me plug this up. All right. So, for example, here we're just importing a bunch of random stuff. So we're importing random integer and random choice and all the ASCII things. So what this little list comprehension does here is all this does is it is going to create a list of tuples that have a key and a value. And the keys are going to be random integers, and the value is just going to be some random ASCII letter. Now, let's say that we wanted to. Oh, go ahead.
I don't know if this is for everyone, but the screen is frozen on my Zoom.
Yeah,
I'm
I
not
can see
seeing
it
the type
either.
of thing.
Oh, whoops. Okay, thank you. Okay, does it work now?
Yes.
Okay, awesome. Yeah, apparently I paused my screen and now it's unpaused. So if that happens again, please let me know. But yeah, so this is the example from the curriculum page for today. It's close to the list comprehension section, but right above it. So if you guys want to go through or copy it on your own to your own computers, feel free to do so as well. So it just imports some random things. It imports random integer, the choice module, and all of the lowercase letters in ASCII. And then it creates a list for us of tuples that have a random key and a random value. And it does that. I guess it creates a list of 10 tuples. And let's say, let's say we want to just print out our random tuples just to make sure that this thing works. I'll just put here down here, and we'll run it. And as you can see, we get 10 tuples. The first ones have some keys, and then we have some values after. But now, let's say that I want to sort this list of tuples. So, well, the first way I can do it is I can do randtupes.sort, and it'll just sort itself, right? And if I run this, so as you can see over here, this is the unsorted list of tuples, and this is the sorted list of tuples. And the sorted list of tuples sorts by the first element in the tuple. So it goes from 0, then 1, then 5, then 7. But let's say I don't want to sort that way. Let's say that I want to instead sort by the letter, or the letter order. And that is where your lambda function comes into play. So this is similar to what Lizuka was just talking about using lambda functions and various maps and filters. We can also use lambda functions for our sorts. And here, what you use the lambda function for is we're going to sort, and actually I can do that right here too. If we run the sort function, it says key equals, and let me see, can I get lower? Okay, well, that's it. I was hoping it would give more information, but it did not end up doing that. So basically, the key is going to tell us, okay, am I going to sort by the first index, the second index, something else? And that's where our lambda function comes in. It says, hey, for any given pair, for any tuple, I want to return the thing at index 1, which is the second element in our tuple. So our sort function is going to sort off of index 1 in every pair, which is basically going to be the second element. So if I run this time with that change, here it starts out with 8S, 7J, blah, blah. Normally, if we were to sort it, it would put the 0 element, the 0V, first. But because we've set here for it to sort by the second element, it's going to sort by the letter. That's why we're starting out with A, then another A, and B, and then F, and we're ending with V. So that's one usage of lambdas for sorting and within a function. And you'll see that more and more as we get into more complicated functions, not just right now, but I just figured it would probably be a good idea to introduce you guys to it while we're going through lambda functions. So I'm not sure if that cleared things up or made things more complicated, but does anybody have any questions?
Yes, would that pair work if randtupes was a dictionary? Would you be able to sort by values using that expression on line 19 if it was a dictionary?
That is actually a really good question. I don't believe it would, but we can try it. So let's see. So I'm just going to here. I'm just going to delete all of this, and we'll just say dict1 equals 1, 10, 2, 5, 3, -10. Just to make it easy. So if I were to
I thought
do
you couldn't sort a dictionary.
well, that's correct. We can't sort a dictionary on its own. But what we can do is we can make a new dictionary that is similar to the first dictionary, but sorted. Does anyone have any ideas as to how we might be able to do that?
Well, I would take the approach of iterating through the items and just populating a new dictionary with those values, but I'm not quite sure how you would sort them. I think I've tried doing it. I don't know the words for this, but like changing a dictionary to a tuple and then sorting that tuple and returning it as a tuple. But
Okay.
I'm curious.
So what about if you ripped all the keys out and put that into a list and then sorted the list and then you printed out, you returned the key value pair by the key.
Pretty much that's what we would have to do. So we could say keys1 is going to be dict1 dot keys, right? I got values1, give me dict1 dot values. And now comes the fun part. So I'll do the option that you're most likely to see and do at this point, which is going to be, let's say, tuples1. And that would be, let's say, key value for key value in keys1 values. Should probably work. Print tuples1. Yeah, run this. Okay, never mind. Here. Before I jump into what I'm trying to do here, though, does the syntax that I'm using make sense?
Yeah, I mean, this is what we just learned, the miscomprehension.
Yeah.
What you asked, sorry.
So I was just making sure, does the syntax that I'm using here make sense? So I'm saying like key value for key value in the keys and values lists. So we're just turning the dictionary into tuples using a list comprehension. Actually, there's a little bit of a better way to do this. We could probably do instead, and we could just do dict1. See if that works. There we go. So again, we're going from the dictionary, which is 1, 10, 2, 5, 3, -10, and just turning it into tuples, which is what we have right down here. So, as I believe James stated quite correctly, you cannot sort a dictionary. But can we sort a list of tuples? The answer is yes, of course. That's what we just did. And what we can do for that, again, is we can do, let's see. There we go. Tuples1 dot sort. And now here's where, again, we have our key, which is our optional parameter. And now we bring in our lambda, like dict item. I'll just say dict item 1. And then we're going to print tuples1 here. And if we run this, now we see that our tuples1 has been sorted based off of the second element, which is what we want. And now finally at the end, how can I turn my tuples into a dictionary? I'll say dict2, or we'll say dict1 sorted is a blank dictionary. How can I populate the sorted dictionary based off of what we have in tuples?
You could use dictionary comprehension.
Unfortunately, dictionary comprehension is not really a thing in Python. I wish it was. Well, actually, no. I'll correct myself. It is a thing, but it's just a little bit weird to use. We can try it if you want to. But let's deal with the conventional approach first. No, and then we do dictionary. No, dictionary comprehension. Oh, no. There we go. Okay, I do not know why I'm missing you. But yeah, conventional and then dictionary comprehension. So without using the dictionary comprehension, which is very similar to a list comprehension, that without using that, how would I populate this dictionary? From the list of tuples.
We'd iterate through the items of the tuples using a for loop.
Yeah, we could do like for key value in tuples 1. And then we could just say dict1 sorted, and I say key equals value. That should work. And then we can just do a print dict1 sorted. And if we run that, we now see that, remember, we had our 1, 2, 3. We have our new dictionary, and the order is flipped. We got our 3, 2, and 1. So this is sort of the long way for us to sort a dictionary. It's a little bit complicated, I know. But any questions about why this works? Or the list comprehensions that we used?
So there is no way to use list comprehension or dictionary comprehension. I guess I'm getting that confused with something else.
So there is dictionary comprehension.
Oh, okay.
But dictionary comprehension is a little bit weird. But before we jump onto that, and I'll just show an example because it's not something that, well, we can go into it if you guys want to. It's up to you. But before we do that, though, does anybody have questions about anything I just went through? I know I went through it a little bit fast, but does anybody have questions?
There was one thing, there was an underscore in a for loop in the given text, in the given problem, the original one.
Yes.
Example, and I did not know what that standed for. Oh.
So the underscore there just basically means it doesn't matter. So I think I see what are you looking at?
I just remember seeing it. I wanted to ask about it, but then we were looking at other things, and
it
was right there on the in examples in the lecture. Yeah, right there. Yeah.
Yep, this one. Okay. Yeah. I'm going to delete everything else except this little bit. Okay, actually, I'll keep the imports just to keep things nice and simple. So for underscore in range, why is there an underscore? Well, we could call it normally like for x in range 10, right? That's what we normally do. We say the variable. But look inside here in the tuples. Is any of that based off of x? Based off of the thing we're iterating over? No. This is just a random number, and this is a random letter. So the variable that we're using to iterate here doesn't matter. So because of that, we can just replace it with an underscore. And for us, all the underscore means is that it's like we don't actually care that we're iterating over range 10. We don't care about the 1 or the 2 or the 3 or the 4. That doesn't matter for us. All that matters is we're doing this thing 10 times. And that's why we use the underscore. Does that kind of make sense?
Yeah, thank you.
But that's a really good question. Anybody else have questions about that? Or anything in the examples that we covered previously or things like that? Okay, not a lot of questions tonight. So before I turn you guys loose on the problems, we're going to run through something that Kasib asked about, which is our dictionary comprehensions. And there is a link that I always recommend. Let me see if I can find it real quick. And here, let's see. Now, here we go. And let me go to Delta. Okay, so there's a really good Geeks for Geeks list there for how to do a dictionary comprehension. So one way that dictionary comprehensions are used, actually, here, let me share my screen and we can walk through it through their website because they have really nice formatting that VS Code does not. Share screen, open. Okay, so can you guys see my screen okay? And like the Geeks for Geeks thing?
Yeah.
Okay, cool. So yeah, starting off with this example, this is one of the main uses of dictionary comprehensions, combining two lists. And I'm not logging in because I do not want to. There we go. Combine two lists to make a dictionary. Now, how can we do this normally? Right? Normally, what we would do in order to do this, let me copy this over here. What I would do normally, we would say like my new dict equals that, and then I would say like for I in range len keys, and then put a colon, and then I would say something like my new dict, and then we do keys I equals values I. Like it's not the nicest format, right? Because what I'm saying is, okay, I'm going to create a new dictionary. I'm going to have an index that goes from 0 to 5, 0 through 4, right? Each index in keys. And then I'm going to say, all right, now that I have this iterator, this number from 0 to 4, my new dictionary for the ith key is going to have the ith value. So it's a relatively ungainly way to set up how to make a dictionary. But instead, what we can do here is we can use the zip function, which is similar to some of the stuff that Lazuka was mentioning before about filter and map. It's in a similar family, you could say. And the zip function basically takes some lists and combines them into pairs. So it'll take in keys and values, and it turns them into tuples. And okay, in our dictionary comprehension now, we can go from the tuples to key value pairs. So all this is doing is it's saying, I'm going to return some key value pairs for some tuples in this list of tuples. That's sort of what this dictionary comprehension is doing. So in contrast to a list comprehension, where we can return whatever we want or whatever things in stuff. Here, for a dictionary comprehension, you always have to return a key value pair, which is a little bit annoying. And that's the main reason why people don't really use dictionary comprehensions all that much. Is there anything else to mention here? Not really. I mean, they're basically the same as list comprehensions, but again, specific to dictionaries, so you can't use them to like make a string or anything like that. And Dictionary comprehensions will always return a dictionary. So that's about it for Dictionary Comprehension 101. The Geeks for Geeks article has a lot of good resources in it if you're interested in learning more about dictionary comprehensions. And as always, if you guys have any questions, please feel free to let me know, and I'll be more than happy to talk about it with you. Are there any questions about either of the topics that we've discussed today?